In section 8.2, we covered the basics of hypothesis testing. We learned that the hypothesis testing procedure can be broken down into three parts that I called the beginning, the middle, and the end. We're going to use those steps to test claims about a proportion in 8.3, and then in 8.4, we're going to test claims about a mean. You need to understand the notation in section 8.3 so that you understand how to extract the values you need from the problem and where to enter them on the calculator. P sub 0 is the proportion stated in the null hypothesis. So if you have a null hypothesis, the proportion of something is 0.2, then 0.2 is your P sub 0. X is your number of successes. Remember, it has to be a whole number between 0 and n. N is your number of trials. Lowercase p is your population proportion based on the claim. Z is your test statistic, which your calculator will find for you. Capital P is your p-value, which you will compare to your significance level. P hat is your sample proportion, and alpha is your significance level. You can either extract these values from the problem, or you can use your calculator to find some of the values, such as the test statistic and the p-value. These steps are just written form, outline form of this process. So you might like the flow chart. You may like steps 1, 2, 3, 4, 5, 6, 7. They're the same thing. Identify the claim, put it in symbolic form, give the symbolic form of what must be true if the claim is false, identify the null hypothesis and the alternate hypothesis, identify the significance level, and then here's the button we need. On the TI 83 or 84, go to Stat, Test, and if you're making a claim about a population proportion, choose one prop z-test. Now, if the problem says find a confidence interval for the population proportion, what was that button? Find a confidence interval for the population proportion. Last test. That was one prop z int. The prop was proportion and the int was interval. We're not finding a confidence interval now. We're doing a hypothesis test for proportion. So find one prop z test. You have to enter the P sub 0 is the quantity in the claim, the proportion in the claim. X is number of successes out of n trials. Then you have to choose either not equal to, less than, or greater than. That's based on your alternate hypothesis. You pick the symbol that's in your alternate hypothesis so that the calculator knows whether you're doing a left tail, a right tail, or a two-tail test. And then you hit enter, and the calculator gives you some stuff we're not going to use, but the important things that we need are the test statistic and the p-value. You compare that p-value to alpha, and if p-value is less than alpha, you reject the null hypothesis. If p-value is greater than alpha, you fail to reject the null hypothesis, and then you state what that tells you about the claim. So I have 3 examples of the full-blown hypothesis test. In a presidential election poll, 308 out of 611 voters surveyed said that they believed they had voted for the candidate who won. All right? It helps to just stop and picture what's going on here. There's a pollster outside the polls. There's a surveyor outside the voting poll going, do you think you voted for the winner? Now, I have voted in presidential elections where I thought my guy was going to win, and then I have voted where I knew my guy was going to lose. When I voted for Ross Perot, I knew he didn't have a prayer. I just didn't like the other 2 guys. So you're being asked upon coming out of the poll, do you think you voted for the winner? And 308 out of 611 says, yes, I think my guy's going to win. I'm sorry that there's not been a female presidential candidate. yet, but that'll change someday. Use a 0.01 significance level to test the claim that among all voters, the percentage who thought that they voted for the winning candidate is equal to 43%. Now, this word percentage here is what tells me to use a proportion test, not a z-test or a t-test, what we're going to be talking about Tuesday. Percentage tells me to use a proportion test, so use a 0.01 significance level to test the claim that the percentage is equal to 43%. Helps to underline your important words. That just draws your eyes right to what's important in that sentence. So what's the claim? That P equals 0.43. That claim is false if what? P does not equal 0.343. So what is the alternative hypothesis? The one that doesn't have the equals in it. And what is the null hypothesis? Always has equals. No matter what the claim is, no matter what the anti-claim is, the null hypothesis always has an equals in it. That's the beginning. Hang on just 1 second. You're one tiny notch ahead of me. What's the significance level we're going to use? 0.01. And now I have everything written down that I need to enter on the calculator in one prop z test. So everybody get to this screen. One prop z test is stat and then test and then number 5. Here's how I decide what to type in. P sub 0 is always the proportion listed in the null hypothesis. So P sub 0 equals 0.43. X is the number of successes. N is the number of trials. In this case, X is the number of people that said, yes, I think my guy will win. N is the number of people who were asked that question. And it's very important that you choose the correct symbol here. You're saying either the population mean doesn't equal 0.43, or it's less than 0.43, or it's greater than 0.3. You always choose the symbol that's in your alternate hypothesis, because that's what's making the calculator get the correct value based on whether this is left tail, right tail, or two-tail test. Since our alternate hypothesis said not equal to, I'm going to make sure I have not equal to highlighted so that the calculator gives me a p-value for a two-tail test. Anyone not have all that entered yet? Number of successes. It's right up, right up here for you, Miss Melissa. All right, so when you hit calculate, here's what you have. Some stuff that you need, some stuff that you don't need. The calculator restates what the alternative hypothesis was right there. The calculator's just telling you, I've done a two-tail test for proportion is not equal to 0.43. The test statistic, z equals 3.699. Let's just round it to whatever the directions say on the homework, but right here, let's say 1 decimal place, 3.7. Now remember what that z is, or what the test statistic is. That's how many standard deviations away from the norm that 308 out of 611 voters picking the right, or knowing that they picked the right guy. That's a hard sentence, but yes, z-score is number of standard deviations that this is away from. If everybody just went in and flipped a switch with their eyes closed, roughly what percent of people would vote for the winner? If it was just go in with your eyes closed, flip a switch, and there are only 2 guys on the ballot, it'd be 50%. If you just picked with your eyes closed, then there'd be about 50% for the winner and about 50% for the loser. 308 out of 611 actually picked, or saying that they picked the winner is way different than that 50%. So people believed in who they were voting for. Or they believed they were voting for the winner. The p-value for that test statistic is, now that's the sample proportion. P-hat is 0.5, means 308 out of 611 is about half. That's what p-hat is. P without the hat is your p-value, and is my p-value 2.16 right here? Say no. No, because what? That E means move the decimal 4 places to the left. To do that, I'm going to have to add 3 zeros. 0.0002 if we just wanted 4 decimal places. And is that less than or greater than my significance level? So in step 6, say what that tells you about the null hypothesis. The p-value is what in compared to alpha? It's less than alpha, so does that mean reject or fail to reject? Reject. The significance level, which was 0.01. Correct. So that means reject the null, and reject the null always, always, always means what? Yep, those words are going to be in my head anytime I see reject the null. And then I'm going to look back and see what the alternate hypothesis was. That's why I need to have it written down up here. And here I wrote HA and here I wrote H1, but they're the same thing. I'm accepting that the proportion does not equal 0.43. What does that say about the claim? That means the claim is false. Accept the null hypothesis, and I could put ... That means P is not equal to 0.43. That's just kind of what's going on in my head. But my final conclusion is always going to begin, there is enough evidence or there is not enough evidence. Which one is this? There is enough evidence. There is sufficient evidence. Are we accepting the claim or rejecting the claim? Yep. And what was the claim? That 43% thought they had voted for the winner. Now, after the election, we knew that the winner had actually gotten 43% of the votes. All right. How could there possibly be a winner with less than half the votes? No, there's a legitimate way that a person can be elected president without receiving over half the votes. More than two candidates. Okay. The Republican might get 45% and the Democrat may get 45%, and then there may be Ross Perot getting 10%, but probably not. Ross Perot and my grandpa. So what does that mean about voter perceptions? If the percent who thought they were voting for the winner is not the same as the percent who actually did vote for the winner, what's that saying? This is the hardest question of all. What is that saying about voter perceptions, about what they think? It just means they're not good at predicting the winner. Voters aren't good at predicting who won, because 43% actually voted for the winner, but something other than 43% said they voted for the winner. So yes, let me write. Let's see, voters' perceptions about the winner. Voters' perceptions are not accurate. See this P hat right here? P hat is 50%. That means 50% thought they voted for the winner, but actually only 43% did vote for the winner. So folks aren't good at guessing who won. Any questions? Now, I don't know if that seemed easy to you or not up until that very last mind-bending question. Hopefully it did. I mean, hopefully you have the beginning. Where was the middle? The middle was 3, 4, and 5. And the end was 6 and 7. Hopefully you have the beginning, the middle, and the end in your head clearly enough that that didn't seem difficult, except for maybe that last question. The only reason that it wasn't difficult, the only reason that I got the right answer was because I had written down all the steps. If I just read that problem, picked up the calculator, and got this screen, I wouldn't know what it meant. If this was multiple choice test and step 7 had an A, B, C, and D to choose from, there'd be about a 25% chance that I'd get the right answer, because I'd just be guessing if I didn't have all this stuff written down. Please write it down. If you ask me for help, I'm going to say, okay, show me what you've written down. All right, number 2. This is an interesting problem. And it actually says, this is an interesting problem. An interesting and popular hypothesis is that individuals can temporarily postpone their death in order to survive a major holiday or important event such as a birthday. Have you heard that? Or nurses and folks who work in nursing homes, have you ever seen a family say she just wouldn't let go until her son got here? Or she just wouldn't let go until after Christmas because she wanted to be here one last Christmas. So that's the claim, is that people can choose when to let go and when to hang on. In a study of this phenomenon, it was found that there were 6,062 deaths in the week before Thanksgiving and 5,398 deaths the week after Thanksgiving. Now, if people really had no control over whether they died the week before or the week after Thanksgiving, there'd be about the same number before as there was after. So far, so good? In this study, there were 6,000 deaths before and, well, close to 6,000 after. If people can postpone their deaths until after Thanksgiving, then the proportion of deaths the week before should be less than 0.5. Yeah, because if they don't have any control, the proportion would be equal to 0.5. But if people actually are hanging on for Thanksgiving, I want one last turkey leg before I go, then the proportion of deaths the week before Thanksgiving would be less than 0.5. Use a 0.05 significance level to test the claim. Oops, here's the important words. Here's the claim. Claim that proportion tells me I use a population test, not a z-test or a t-test. The week before Thanksgiving is less than 5%. So there's the claim right there. How do I write it in symbolic form? And I may have said 5%, but I meant 50%. Yep. And that's false if P is greater than or equal to 0.5. So the alternate hypothesis is the one without the equal to, and the null hypothesis is P what? Equals. Always, always P equals. What significance level are we given? That's the 0.05. And now I'm ready for the calculator. What am I going to put in for P sub 0 on the calculator? The proportion that's in the null hypothesis, 0.5. What will I put for X? Well, our claim, P, is about the proportion who died before Thanksgiving. So our X has to be the number who died before Thanksgiving. Does that make sense? Yeah, 6062, 6,062. If your claim is about percentage who died before Thanksgiving, then X has to be the number who died before Thanksgiving. And what is N? The total, not the number after Thanksgiving, but N is always the total. So add those two numbers and what do you get, somebody? Ooh, I think, yeah, it's even because that's 100. Yeah, it's exactly 1,200. And that 1,200 is nowhere written in that problem. So you have to understand what N stands for to know how to find it. It's the number in the sample. Miss Taylor, what's bugging you? Just it is because that's 6,000 and that's 6,000. I needed one more zero. Thank you. A lot of people were frowning, and that usually means I've messed up. On the calculator, am I going to choose the left tail, right tail, or two tail test? My alternative hypothesis says less than, so I'm going to make sure I have less than chosen. All right. Punch. I didn't mean that there. I meant for that to be right there. Punch that on the calculator. Give me a test statistic to 2 decimal places. Because that's the alternative hypothesis. Remember, p sub 0 is 0.5, and the test is that the population proportion is less than 0.5, and that's exactly what the alternative hypothesis was. Oh, okay. All right. You're just going to choose the less than on your calculator. All right. Anybody have it punched and give me z to 2 decimal places? Anybody second that? Anybody having trouble getting that? I'll come see what's going on. What would happen? Oop, let me save that question 1 minute. What are you getting for a p-value? Give me 4 decimal places. Anybody second that? 0.8712. That's a probability. What would happen to that p-value if instead of choosing the less than, I had chosen the not equal to? Yeah, 2 tail. It would give me twice the probability of what's in 1 tail. How does that compare to our significance level? Much bigger than 0.05. And since our p-value is greater than the significance level, what does that mean about the null hypothesis? Failed to reject. And what does failed to reject always mean? Insufficient evidence. We know that failed to reject the null hypothesis means that there's insufficient evidence, but I still am working on determining whether there's insufficient evidence to support the claim or insufficient evidence to reject the claim. And to answer that question, I need to ask myself whether the alternate hypothesis is the same as the claim. If the alternate hypothesis is the same as the claim, then I'm going to refer back to this flow chart and say the alternate hypothesis is the same as the claim. Did I reject the null hypothesis? No, I did not. So there is not sufficient evidence to support the claim. If I had rejected the null hypothesis, I would have said there is enough evidence to support the claim. But because I did not reject the null hypothesis, there's not sufficient evidence to support the claim. So there is insufficient evidence, or you could say not sufficient evidence. To support the claim. And then you could just restate the claim. You could say support the claim that the proportion of people who died the week before Thanksgiving was less than 0.5. But really, this particular problem is not about what percent of people died before Thanksgiving and what percent of people died after Thanksgiving. If the proportion who died before Thanksgiving was less than 0.5, we were going to say that it is possible for individuals to temporarily postpone their deaths to survive a major holiday. If less than half died before Thanksgiving and more than half died after, then it looks like folks could postpone their death. Since we don't have enough evidence to support that, I'm going to word the claim that individuals can temporarily postpone their death to survive a major holiday or important event. We were hoping that the evidence would show that there is sufficient evidence to support the claim that individuals can temporarily postpone their death, but that was not the case. So, does that necessarily mean that this claim is not true? Have we proven this false? No, we have simply proven that this evidence is not strong enough to support the claim. We haven't rejected it either. All right, one more problem. Number 22 says, in recent years, the town of Newport experienced an arrest rate of 25% for robberies. The new sheriff compiles records showing that among 30 recent robberies, the arrest rate is 30%. So she claims that her arrest rate is greater than the 25% of the past. Is there sufficient evidence to support her claim that the arrest rate is greater than 25%? All right, here's the claim. The claim is that the rate is greater than 25% or 0.25. It's the arrest rate. So the claim is that she has arrests in more than 25% of robberies. And that's false if the proportion of arrests turns out to be less than or equal to 0.25. So the one of these two statements that does not have the equals is your alternate hypothesis. P is greater than 0.25. And your null hypothesis always has the equals in it. So the null hypothesis is that P equals 0.25. The alternate hypothesis is that P is greater than 0.25. We are not given a specific significance level here, so I want you to keep this in mind. When you're not given a significance level, I want you to use a confidence level of 95% or a significance level of 0.05. Use that whenever you're not given a significance level. In step 4, the proportion in the null hypothesis is 0.25. What does X stand for? The number of successes. Could the number of successes be this 0.3? You can't make 0.3 of an arrest. Her arrest rate is 30% of the 30 recent robberies. How do you find how many arrests that is? 30% of 30, 0.3 times 30 is 9. So there were 9 arrests out of a total of 30 robberies. And remember to select the symbol in your alternate hypothesis. Make sure you choose the greater than on your calculator. So this is, let me enter this real quickly. This is what I have on my calculator. The proportion in the claim is 0.25. I had 9 arrests out of 30 robberies, and I've chosen the greater than symbol that was in my alternate hypothesis. So here are my results. The z-score is 0.63 if I just round it to 2 decimal places. The p-value to 4 decimal places would be 0.2635. And I need to compare that to my significance level of 0.05. 0.2635 is much bigger than 0.05. Since our p-value is greater than alpha, does that mean reject the null hypothesis or fail to reject? If p is greater than alpha, we fail to reject the null hypothesis. Fail to reject the null hypothesis means there's insufficient evidence one way or the other. So I'm going to start this conclusion. There is not sufficient evidence and then I need to determine whether I should say not sufficient evidence to support the claim or reject the claim. In order to determine that, is your claim the same as the alternate hypothesis? Yes, it is. If the claim is the same as the alternate hypothesis, did I reject the null? No, I did not. So once again, there's not sufficient evidence to support the claim. There's not sufficient evidence to support the claim that the new sheriff's arrest rate is greater than the 25% of the past. Now, in the three examples on the handout, I just happen to have one problem on the front page where we rejected the null hypothesis. But on the two in the back page, I failed to reject the null hypothesis, and it just so happened that in both of those, there was not sufficient evidence to support the claim. Remember what would cause me to write not sufficient evidence to reject the claim? That would be if my alternate was not the same as the claim, and I failed to reject the null hypothesis. If the claim and the alternate hypothesis were different, and I failed to reject, then there would not be sufficient evidence to to reject the claim. All right, that should be everything you need to begin the section 8.3 homework. Good luck.